In this tutorial, we will load in custom clutter data for a training area out here in the desert. So here we've got some buildings and we've got SOOTHSAYER connected to our ATAK server. In the clutter menu, we can define different clutter. Now, a path profile here shows there is no clutter data where these buildings are. So we need to fix that. We need to load in some clutter. First of all, we need a profile. We create a profile. We set the height and the attenuation for the materials that we're interested in, and we give it a distinctive name, NTC. We now open the clutter tool and select the predominant material type, brick. And now I'm loading in a GeoJSON file. The blurring is intentional. And this GeoJSON file contains the building footprints, the heights, and the material type. We're also going to add some trees, so the British players who are taking part in this exercise feel at home with a square wood block. The trees have their different attenuation levels, which you'll see shortly once we model some coverage. So we're now going to run a short calculation using an L-band radio, and we can see straight away this precision clutter is showing substantial attenuation where there are obstructions and different attenuation levels for the two types of trees. Now let's bring in that app, and you'll notice we've got some very basic mapping going on in the app here. We've got SOOTHSAYER in the chat channel. Let's pull in our clutter because this is linked to our account. So we send the keyword clutter, a data package is fetched. This is the custom clutter that we just loaded. You can see the tree blocks here. And we can now work with this direct from ATAK. So using the draw tool, we go and define a circle with a center point and a radius. Send that circle to SOOTHSAYER, and the coverage will be modeled using the template that is defined. This minimizes user error whilst maintaining that high precision and exploiting the high precision data. So here you can see the path loss attenuating through the buildings and through the gaps in the buildings. This is quite a challenging area, and we've made it extra challenging by setting these buildings to be very dense to get the most conservative prediction possible.